Okay, so we're going to start with the outside of your foldable, and we are going to be looking at the parent function for quadratic equations, which is f of x is equal to x squared. Now, this particular equation is in standard form, which is this we have right here with A, B, and C being coefficients. So the first thing that we need to do is we need to define our coefficients. What's A, what's B, and what's C? So in this case, our A would be the coefficient for x squared. The coefficient for x squared is 1. Then we have B, which would be our coefficient for x, but because we don't have an x, our B is 0. And then we have C, which would be our constant, but because we don't have any C over here, our C is 0. So those are the 3 things that we need to find first. Once we find those, then we need to find the axis of symmetry. So we use this formula that we talked about in class, x is equal to negative b over 2a. So I'm going to take what we have up here and substitute it into our function, into our equation. So we end up with x is equal to negative 0 over 2 times my a is 1. Okay, so we automatically know you can't have negative 0. So then that just turns into regular 0, and then we have 0 over 2, which we know that 0 over 2 is 0. So my axis of symmetry is 0. So what I'm going to do now that I have my axis of symmetry is I'm actually going to draw it down here on our graph. So we need to draw our x and our y axis first. So we'll just put, oh no, wait. Let me go back. Change my pen. There we go. All right. Draw x and our y axis first. This is our y axis, and this is our x axis. And if it helps to actually label them, this is the y axis, and this is the x axis. And so we said that our axis of symmetry is that x equals 0, which means it's the y, and it's going to be there, and that's very crooked. So let's try that again. Actually, let's draw one. Boom. That's there. All right. Now, the next thing that we need to do is we need to figure out what the vertex is. So our vertex is going to be using our formula that we have at the top. So in order to do that, we just take what we have for x, and we're going to actually substitute our x in the function. All right, so I have that x is 0. My function that I'm starting with is f of x is equal to x squared. So everywhere I see x, I'm going to put 0. So I have f of 0 is equal to 0 squared, and everybody knows that 0 to the second power is 0. So that's my answer. So I'm going to write my vertex as an ordered pair, 0, 0. And then what I'm going to do is I'm going to go down, and I have 0, 0. Actually, let me do that in a different color so it doesn't look the same. We got 0, 0 down here at the bottom. That's my vertex. And so from there, we're going to actually rewrite our equation technically in vertex form. So we're going to use f of x, and then we need to figure out what's h and k, because we already have a, because our a was given to us at the very beginning. Our a is at the top, which is 1. So we need to figure out what H and K are. Well, the vertex is H and K. So this is my H. This is my K. So we're going to take 0 and 0 and substitute it in for H and K. Well, if I substitute 0 in here, it's not going to really change much. If I plug in 0 here, it's not really going to change much either. Also, if I plug in 1, which I can, I would end up with 1 times x minus 0, which is x squared, and then I have plus k. So it doesn't really change too much. From there, we need to start graphing. So in order to graph, I like to use what's called the 1A, 3A, 5A rule. So you start from your vertex, and then we're going to go to the right. So we're going to go to the right 1 and up 1. That's our 1. And then we have 3A, so that means we're going to go to the right 1, but this time we're going to go up 3. 1, 2, 3. Sorry. We're going to start from here. Go to the right 1. 1, 2, 3. That puts us up at the top. And then we couldn't do 5 because from 5, if I go over 1 and try to go up 5, it puts me off the graph. So now I have these coordinates here. Now, what I know that I can do is we said that this is our axis of symmetry and that parabolas are symmetric. So I know that I can just reflect each of these points on the opposite side of my parabola. And then I'm going to connect them and draw my U shape. Now, making my table over here, we're going to start with our vertex, put our vertex in the middle, and we're going to count backwards, -1, -2, and then we're going to count forward, which would be 1 and 2. So then this order pair is this point right here, because we went over 1 and up is this one. I'm sorry, this one down here. We went over 1 and up 1. And then we went over 2, and then this coordinate is 1, 2, 3, 4. So that would be 4. And then what did we do? We reflected it on the other side. So I can either say over 1 to the left to -1 and up 1, which is here, and then over -2 and up 4. But if I look at my graph, it's reflected. If I look at my table, it's reflected. It's 1 here, 1 here, 4 here, 4 here. So it's always going to be a reflection. The last thing that we need to, the last two things, we need to look for our roots and our zeros. So another word for that is x-intercept, which is where our graph crosses the x-axis. So my graph crosses the x-axis here. This is my x-axis. It's crossing here. So I'm going to put x. I'm going to use my braces, and I'm going to put 0. Close my braces. That's how you write your intercepts. And so we're going to write it in what's called factored form. So again, our A is 1. And then we're going to have x minus 0 times x minus 0, because we only have 0 as our roots. Remember what we said in class about our domain, all real numbers. Let me use that abbreviation for numbers. And then our range, we look at our vertex and see if it's above or below. So I started my vertex, which is the y, and it's above, so it's greater than 0. So this is the first example. Go ahead and click to the second video so that we can go to the second video.